Hello and welcome to the new segment of Ad-hoc Network, which is actually one of the important concept, or we could say one of the important parameter that we need to consider while we are learning about wireless network. So yes, ad hoc network. So what is ad hoc network? So in general, we know whatever is ad hoc is actually a temporary thing. So whenever it comes out to be a ad hoc networks, so it becomes a common sense to say that ad hoc network means a temporary network. So today what we are going to do is we are going to cover some of the introductory things about your wireless ad hoc network, and also we are going to take some conceptual and technological overview of this wireless ad hoc networks. So well, Uh, ad hoc networks are actually a class of wireless network which are known as infrastructure less network. So if I'm going to ask you something like that, so please tell me which one of these two is, you could say that these are actually a infrastructure less. So just network is supposed to, okay. So from diagram we could easily say that obviously these network, so it's infrastructure less network. Okay, so what is this thing then? So these are actually called as infrastructure based wireless network. Okay, so whenever you need to understand wireless ad hoc network, you need to completely keep that in your mind that wireless networks which are infrastructure less are called as ad hoc networks. Okay, so wireless networks can be classified into, actually now as per these diagrams, into two types, which is called as infrastructure based network and other one is called as infrastructure less networks. So the infrastructure based networks are those which rely on fixed infrastructure. So like in this particular diagram, it's a fixed infrastructure that yes, this access point is going to provide access to this mobile node or your laptop. So it will be from your distribution system that this access point will receive one connection from this distribution system. So there might be a tapping, then again there will be a FTP, the file server you could say, and your web server is there. Your wired network will also be associated with this thing, like your PCs will be there, your printer and all those devices, whatever you need to deploy a scanner. So these kind of distribution and all the ethernet internet based systems, all individual node in this particular network are actually called as your infrastructure based based systems or a network. Okay, so these are actually called as a fixed infrastructure. This could not be moved, and yes, if you need to insert something new, you could, but that thing needs to be understand by a network. It's not something like that if you feel I need to add into in a network dynamically, you could not. You need to deploy some kind of process into your system or your MAC address, something like that, into your system, then only it will happen to be a infrastructure based network. Okay, so in general you could say that they have some kind of equipments such as a base station or a access point which are fixed and centralized. Okay, so example of infrastructure based network are like your wireless local area network or your cellular networks and so on. So because as we know that wireless local area network or cellular networks, they have devices known as access point or a base station. So these access points or a base station, they basically help in transmitting or routing information that is sent from your individual node to a destination node. Okay, on the contrary, In infrastructure less network category, there is no, actually we could say there is no centralized access point. So as we can see in a figure, that it's actually, this figure will tell you that yes, there is no kind of a distribution system that who will communicate to whom and all those things. So it's just a combination of your PC, your iPad, your laptop, your PDA to uh, some, we could not say a centralized point, but this creates a ad hoc network and it is being connected with your internet. So I don't understand this, what kind of process is going on. So that is actually called as your ad hoc networks. Okay, so I just forgot to write here, this is called as ad hoc network. So these are actually infrastructure based networks and these are infrastructure less. Okay, so in this we could say that we have different collection of a uh, we have a collection of different nodes, which could be like your laptops and all those things. So they could so there is, we could say that there is no fixed entity like your access point or a base station, unlike the other figure which says that every node in the case is actually connected to some access point and then to a distribution system or then to a your connection oriented systems. Okay, so here we do not have such thing in infrastructure less network. So ad hoc networks that we talk about uh, belongs to infrastructure less network category. Okay, so in general, what is now the wireless ad hoc networks is nothing, simply like if I would explain you this thing, then it would be like, for example, you have your one phone. I'm not going to draw it again, so I'm just writing it as 1 2 3 4 5 and 6. So this is your one. So these devices are connected in a kind of random fashion will do, that this is connected to this is connected to this, then this is connected to this is connected to this is connected to this is connected to this. So this is kind of a rough architecture. If the new node arises, then we can easily add up into this network. So we could create actually a channelizing. So yes, so there we could say that it's a smaller example of your wireless ad hoc network. So as we can see that in such a network, we have actually collection of different wireless enabled nodes which can communicate with one another, as we have already saw. So there is no base station, no access point. So we can see over here that nodes, that these nodes, uh, they are in a proximity of each other. It's not simply like they have a distance of larger, we could say distance. So it's actually a smaller distance, or we could say in a proximity. So they can communicate with each other and they can form a topology. So it's not kind of a fixed topology, so it's a random topology. In this topology, that they can move, and due to mobility, the topology of network, they change over a time. So obviously we could not say that in this particular thing there is a fixed topology. If I would just say is mesh, then no, it could not seem to be a mesh. You could only say it's a random topology. So it's their choice, they want to go as per their requirement, they'll create it. Okay, so you will ask then, so what is this wireless ad hoc network then? So yes, wireless ad hoc network is simply like, we could say these networks, they are actually known as your multi-hop networks. So whenever it comes out to be ad hoc network, we need to always consider some of the point, which is also called as multi-hop network. Okay, so they do not require any fixed infrastructure. Okay, so we have already seen that. So I'm just going to write some of the key features so that it will be easy for you whenever you come back to see this video. So it will be easy for you. So no fixed infra. All right. So these are actually multi-hop network, as well as they do not require a fixed infrastructure. So what happens is, if the source node wants to communicate or to have some information, that means source node wants to send some information to a destination node, it has to take a help from intermediate node in order to be able to send data that it wants to send. Okay, so basically the intermediate node, they act as a peer node. Okay, and these peer nodes, they take a part in relaying the information from source to a destination. So these networks are self-organizing and they are self-configuring. Okay, so whenever it comes out to be a ad hoc network, so these are actually what we could say self-organizing, okay, and self-configuring. So they has to be self-organized and self-configured. All right. So uh, once you have collected the different nodes and you put them together, they would be able to form a network by themselves. And you know that different nodes, they would be able to start communicating. So obviously, for example, I need to start from my source node, and here it's some kind of a network. I'm just giving a dummy network. If I need to have some kind of data and I just want it to be shared to a destination, so in some of the test cases, like we could say in some of the technologies like IoTs, you have already seen that whenever you want to send some information, or you want to access some sensory data to a destination, so what kind of process happens? But here in ad hoc network, it is a similar case, that it's a temporary network. They do not form a particular topology. These are not a fixed infrastructure thing. So they do their own stuff. They self organize, they self configure, and they will be able to communicate with source and destination. Okay, so the reason they are called as multi hop is uh, that what we could say, from the source node to a destination node, uh, if the destination node is not within a direct transmission range. So simply, like for example, there is a some formulative distance between source and destination. So in that case, you will say this is not a direct transmission range, that there is no direct connection between source and a destination. Okay, so in that case, then source node will have to take some help of an intermediate node. So for example, you need to transfer some courier to Delhi from Mumbai. So in that case, it will not be possible that you alone will go and carry that particular parcel or courier to Delhi and come back. So in that case, you need to take a intermediary services. Like you go to some agencies and they'll forward that particular thing on behalf of you. Obviously, it will be a paid thing. So that kind of process is actually ad hoc process. Okay. So in this process, or in a previous process also, wherever you were transferring your courier, or you're sending your courier through an agency, so what it does is, uh, you go there, you pay your money, they will make a weight and all those processes, and after that they'll deliver your parcel to Delhi, and then there is no relation between you and the destination with the help of that guy. Okay, so he just made a, what we could say, a temporary connection on behalf of you, or he has collected a data from source from you and delivered it to destination. And later on, there was no role of, later on, I am saying later on, there was no role of that agency. Okay, so what data was sent? So that is actually a process called as ad hoc. So consequently, what happens? It's not a single hop transmission from source node to destination node, but it goes through number of multiple hops. So multiple number of intermediate node. Consequently, what we have is multi-hubs structure. Okay, that means the data is transmitted, goes through a multiple hops from sender to the intended destinations. Okay, so maybe possible that from this transmitter this could go first to this, then later on to this, later on to this, later on to this, and then destination. Maybe possible that it could directly go to this, then maybe this, and there is actually minimum weight and that kind of things are there. So those kind of algorithms are also used. So even in an example we have taken for a courier, actually that could be also a multi-hop. That obviously you're you are a source, you're giving your parcel at courier, and here it's a destination. You just only understand that मैंने courier यहाँ दे दिया, and I'll be able to deliver that parcel within some stipulated time to a destination with the help of this courier service. But in this courier service there could be a multiple hopping system, that this courier will go to some other place. Like for example, you are delivering it from Mumbai. So in Mumbai, in which location you have shared it, it will go to a centralized location. Then again it will go to some collection unit. Then from that collection unit it will be delivered to something else. And then after taking a multiple hop, it will reach your Delhi or a destination. So likewise, that's why this system is called as multi-hop system. Okay. So these networks are very useful in actually a different situation. So when it is like different times of emergency or during your relief operations. So let us consider the different few example from history. So let us say that when you know like September 11 incident, that so what happened is entire infrastructure in building as well as in a network infrastructure that was there, it was actually collapsed due to that entire disaster of September 11. So once the existing infrastructure collapses, it is actually, you could understand that it's very difficult for the rescuer to perform a relief operation. Okay, so people who are doing a relief operation, they they were not able to communicate with each other due to that entire collapsation. So because we know wherever it was existing, it's not there now. So in that case, what did they create is actually a ad hoc network they have created. And later on, depending on that, they have they had been able to, we could say, communicate efficiently. So what is required is that in order to able to efficiently communicate between your different rescue workers and different victim, etc, what is required is to have some kind of mechanism by which network can be set up faster, and so that you can your communication can be restored. So ad hoc network come to an useful in kind of scenario, because that it's very easy to set up a network in such scenario. And also the cases like in a desert area or in the remote areas where there is no existing infrastructure, in that case also these ad hoc networks come, we could say, they are very useful in that kind of cases. So next we could go to something like, I think this is enough for intro. So depending upon deployment and different topologies, we'll see how their ad hoc networks are classified. So there is no much planning that can be afforded to set up these kind of networks. So that's why these networks prove to be very useful. So ad hoc networks, depending upon a topology and a deployment, they can be classified into two different types. Okay, so what are those two different types? So one is called as your homogeneous, and other one is heterogeneous. Okay, so first one we would write homogeneous and heterogeneous. Okay, so depending upon this two deployment and we could say topology and deployment. Okay, so parameter considered here is topology, deployment. Okay, so these are two different categories. One is your homogeneous and second one is heterogeneous. Okay, so in homogeneous network, as we can see that we have seen already a figure. We have a different nodes in a network which have similar characteristics. So like mm, I think I would take one diagram for this homogeneous. So there is one mobile handset, there is another mobile handset, and yes, this would be enough. So this is communicating to this is communicating to this, and again he is communicating to this. So this is your first node, this is your second node, and this is your third node. Okay, so what we have is actually a different nodes in a network which have similar characteristics. They have a similar specification, and you know that they are all very similar. So an example of this kind of network is actually a network formed by your smartphone, which have to be a similar specification and capability. On the contrary, heterogeneous ad hoc network where all the nodes may not be a same type. Means like in a heterogeneous there could be like this is one kind of your phone, this is your iPad, then there could be a PC. So this is actually 1 2 3, so maybe possible they are again communicating with each other. So so these are called as actually heterogeneous things. Okay, so uh, these are actually could consider in general that they are not a similar types. They may not have maybe they may not all have a different they may not have a same or a similar kind of specification, but even they could have a different capability and so on. So these are actually heterogeneous things. So an example could of these kind of network could be PC, smartphone, tablets, the combination of all those. So these could be said to be a heterogeneous wireless ad hoc network. Okay, so I think for heterogeneous and homogeneous, I think it's quite clear. Same specification. I could not say exactly all Samsung phone or all Apple phones, but in general, same specification, same capability. Here could be or could not be same specification and different capabilities. What you could do with mobile, maybe you could not do with your PC, maybe you could not do with your PDA or your iPad. So these are homogeneous and these are heterogeneous. Okay, so I'll just briefly get into your some part of history because that's always an important part. So now let's just look at a bit of history of your ad hoc networks. So the concept of ad hoc network was is we could not say that it's quite new. It actually started in your 90s 1970. Okay, so with a DARPA project, it was actually called as DARPA project, known as the Packet Radio Network Project, which was actually PRNet project. So the whole purpose of the, or we could say, objective of project was to enable a communication in a battlefield between your different wireless devices, so that your different terminals could communicate with one another. Okay, but the main problem those days in 70s and so on was, even though this concept proved to be useful, it was successful just because they demonstrated kind of a mechanism that you could be deployed at any time anywhere, and at that point it was actually a very bulky processes were there. So even though in a packet radio network project was quite popular, uh, after that there was no much of advancement in these kind of things. So in 1980s and all those things, it was actually slightly developed, and in 90s 80s and 90s, the wireless devices become actually very portable, and consequently the concept was demonstrated in your packet radio networks, was actually quite brilliantly implemented in these scenarios of 80s and 90s. So it was actually quite relieving to use these kind of networks in disaster or in relief operation. So you could understand that once network goes on, or once these kind of ideas came into picture, so it's actually a quite implementable thing. So the advantage of having such a network, uh, or having these networks in a deployment, was rapid deployment, or just because they were having a self initializing, organizing, and there is no such requirement of network management administration problem. So disadvantages of, we could say, of these networks also belong at that time, that there is actually a kind of, you could say, not many advantages, but many advantages are there. So for example, although it's very attractive to have the kind of network, but there are actually a basic problems, like with respect to your medium access. So whenever you have several of node, there is no centralized coordinator or access point, so which can help your different nodes. So it becomes actually medium access becomes a huge problem. So similarly, like traditional problems in the networks are like error control, flow control, routing, and so on. So including like in a even transport issues are there. So those become very challenging in these kind of networks. In fact, without addressing these kind of problem in a newer concepts, so these PR networks become very inefficient. Okay, so this was actually a rough history, that why we had gone to ad hoc network. Okay, so we'll just briefly see what are these general concepts in your ad hoc network. So let us now look at some of the concepts in ad hoc. So these networks, they belong to like a broad category of wireless network, all the distributed wireless networks. So as this name suggests, in network, the different nodes, they are distributed in space, and nodes to be able to communicate with each other. So there has to be some kind of mechanism which will enable this node to be able to do these things. So because there is no centralized entity, there is no centralized access point, or what we could say a base station, uh, which can help in centralizing manner. So these networks and the nodes in them, they operate in, we could say, TDD mode, so time division duplexing mode. Okay, so I think you know TDD from past few years of experience, time division duplexing. Okay, so I think you understand the mode, time division duplex mode. Okay, so that means it's that half duplex mode. So that means half duplex means it's not possible to receive and transmit data at a same time instant. Okay, so that's why it is called as your half duplex mode. So having said that, let me also tell you that what what is existing, but currently, uh, this is what was existing, but currently there have been different works, in, you could say, in a decade or so, there have been a different works which have considered a solution for full duplex network. So that means it is possible in current scenario to be able to receive and transmit data between your source and destination at the same time. So in these networks of a neighbor node, they can communicate with each other using your single hop wireless technology. So for example, Bluetooth could be used, or Zigbee, or your IEEE 802.11, which basically powers Wi-Fi, as you know. But not 802.11 in Wi-Fi mode, but in ad hoc mode. Okay, so if you want to deploy a 802.11 thing, so you could not actually, you already know 802.11 is your Wi-Fi, or what we better say is wireless local area network. So these could be actually used as a ad hoc network, ad hoc wireless network. So if you want to use this wireless LAN technology as a ad hoc network, in that case you could not use it as a Wi-Fi. You need to use it as a in a ad hoc mode. Okay, so these are some of the names that you know, which enabling technologies behind your ad hoc networks. Okay, so the nodes which are at a distance from each other, that means the node which are not within a direct transmission range of a particular node, these two nodes can communicate with each other. Only the thing is, you need to hire a sequence of intermediate nodes. So the intermediate node would have to cooperate and forward the traffic that they receive from a source node. So that is why uh, that is why it is actually, we could say, we generally prefer them to be a multi-hop network. Okay, so now we could say, okay, fine. So enabling tech, we need to see. So what were the different enabling techniques are there? So let's once again, I could say that how many techniques I could incorporate in ad hoc network. So in general, first I could say your Zigbee is there. So do you know what is the IEEE standard for Zigbee? So it's IEEE 802.15.4. So this is actually a short range. All right. So approximately you could say nearby to 100 meter, and low data rate. So how much low? So we could say less than 250 kbps. All right. What could be another technique that, yes, what we have studied and what we know? So it's Bluetooth. So what is IEEE standard? So IEEE standard for this Bluetooth is IEEE 802.15. I'm sorry, 802.15.1 is your Bluetooth. So Bluetooth is, obviously this is also a short range. It is less than 10 meter. So if I need to write, I'll just write it in a short. So 10 meter, and this is actually, we could say, this is actually a PAN, personal area network. All right. So data rate are actually, we could say, in which version we are talking. Depending upon that, you know it better, whether it's 2.0, 4.0, 4.2, whatever. So another thing is like yes, you could say we have discussed Wi-Fi. So we'll write just Wi-Fi. So IEEE standard for your Wi-Fi is 802 point what 11. You could use 11, but this has to be used in a ad hoc mode, not in Wi-Fi mode. All right. So we could say this is actually a high speed, medium range, mobile ad hoc network. All right. So the next is we could say 802.16. So just understand what is 802.16. So do you know what is 802.16? If you know, just put me a or ping in a chat section. So what is 802.16? So yes, you're right, it's y max. So even y max could be used in your ad hoc network. So that is actually a vast thing. Even the wide availability of your 802.11 NICs, so they could be mostly used. Okay, so we could say these are some of the techs used in your, or we could say enabling technologies are used in your ad hoc network. Okay, so let's just uh, we could say we could classify, but before that I think mm, yes, some of the things I have left previously. Okay, for yes, I think I have covered up much of the parameters. So I think for this I have just forgot to express a speed 54 sorry, not kbps, it's actually 54 mbps. All right, so the distance could be covered up by this thing is actually greater than these twos, so it could be like 200 meters, 100 to 200. I could not dynamically say 100. So some of the configuration in this Bluetooth or Zigbee, we could say uh, Zigbee could be used in your like home automation and smart grid. You have already been used. So it's actually a for Zigbee, the advantage is long battery life. Okay, and this could be this will be operating in a master slave configuration. I just forgot to tell you those things. And here is actually in a Bluetooth, we could say the important feature is actually authentication. Encryption is actually important parameter, encryption. And we could say here configuration is like even master slave, but 8 active devices, piconet, scatternet, that kind of thing could be included here. So even here it is a master and slave, but in a mode of scatternet and piconet and all those things. mm, in a Wi-Fi and in this both, we could say this is actually a peer-to-peer, you could say that. So in a Wi-Fi you could use 802.11 G. Okay, so I think this much is enough. So okay, so we'll just, instead of moving directly to classification, I think before that one more parameter I'm missing to tell you this thing. So as we already know that if you have taken a basic courses in that, oh, what was the subject, networking related subjects. So we know that there is actually a 7 layers in that OSI architecture. So 7 layer or 5 layer architectures are there, or like in OSI and TCP IP architecture. So that is typically used in actually a traditional network. So though those networks, uh, they can also be translated and can be borrowed in forming actually ad hoc networks as well. So the only difference here is we have to keep in mind that we do not really have a single hop kind of network, but we have a multi-hop kind of scenario. I have already explained you what does it mean by multi-hop. So there are different functions of network, whether it is ad hoc or non-functions with respect to routing. Routing is actually an important function. So routing means that from one point to another point, how to send the data, and what are the different paths that are available or that can be made available to the packets. So the routing basically takes care of determining the paths between your sender and receiver, whereas forwarding basically takes care of actually forwarding the packets between your intended source and destination node using your routes that are determined through routing. So routing forwarding is one and the same thing, we could say. So we have a link layer, we have a network layer. Routing, forwarding are important functionalities of a network layer. On top of these two layers, we have is a TCP, that means a transport layer, which basically takes care of your transmission control. So we'll see different challenges adopting TCP in your ad hoc network. So we'll see that little bit later, or maybe later on. So let's just get into actual classification of your ad hoc networks. So whenever we say those things, so whenever it comes out to be a wireless ad hoc network, so those are actually divided among actually into in four different types. Okay, so the first one is your wireless ad hoc network. So we'll write wireless ad hoc network. Then second one is your mobile ad hoc network, or we better know them as manet. Another thing is there, which is actually a vehicular ad hoc network, which is better known as vanet. And one of the important that you must be already knowing, wireless sensor network, which was better known as WSN. So if I'm giving everyone a name, so these are known as actually WMN. Okay, so let's just move forward and let's see different aspects of your ad hoc network. So wireless ad hoc networks is actually a broad class of your networks. So these wireless ad hoc networks, they can classify into different types. So we already have seen those things. So what are those? WMN, manet, vanet, and your wireless sensor network. Then we could say just a little bit of I think we must move forward, because if I'll explain it here itself, then it will not be a fun for wireless ad hoc network like manet. So I think today's scope is actually your this wireless manet and vanet. So if I'll discuss it entirely, then I'll be disturbing other stuff. Okay, so I'll just move on with the types of ad hoc network. So whenever I'll say it's a manet, mobile ad hoc network, in that case, how could be a mobile ad hoc network? So we could say that we have a mobile ad hoc network, something like we have one laptop. I'm not drawing better laptop, but still consider this to be a laptop one. There's another laptop. Okay, this is second one. There is one phone. Okay, then what more we could draw is actually your iPad is there. Okay, so something like that. Okay, different nodes with different specification or capabilities, so they are connected in some fashion, like maybe like this. Okay, so everyone is participating, yes. Okay, so we have a mobile ad hoc network as we see in this figure. So this is actually which kind of network? So whether it is homogeneous or heterogeneous, just put that particular thing in a chat. Let me see whether you understand heterogeneous or homogeneous. So this is actually a heterogeneous ad hoc network, not homogeneous. Okay, so we have already seen what does it mean by heterogeneous. So in a particular case, this is heterogeneous network. Okay, so we have different nodes. Okay, so we could say that different nodes which may or may not move. So we have all the nodes in a network, they move consequently, they are known as mobile ad hoc network. Okay, so these kind of networks are called as your mobile ad hoc network. So what is your mobile ad hoc network? So those mobile ad hoc networks have actually we could say we have different capability. Okay, so the first thing we could note about this mobile ad hoc network is these are actually infrastructure less network. Okay, then another thing we could say, yes, they could be self configure, they could be self, I'm sorry, they could be self heal. What more, they could be self optimized. uh, they could be like self protect. mm, yes, this much could be enough properties of those things. So okay, so these actually have some of the properties like uh, uh, self chop property, these are called as. Okay, so in general whenever you see something like this, so these are actually considered as self chop. So don't consider this to be a one thing. So this is actually a self configurer, self heal, self optimize, and self protect. Okay, so that's why in many of the books or many of the articles you will see that mobile ad hoc networks have a self chop properties. So don't consider they'll chop itself. So chop means configure, heal, optimize, and protect. All right, so uh, obviously I don't want to repeat it again and again, but you need to understand what is chop. So we have self configure, they can heal itself, they can optimize, they can protect, which basically characterize this entire network. That means mobile ad hoc networks, in mobile ad hoc network, due to actually we could say in a mobility or there are actually frequency link changes. Consequently we have actually very dynamic kind of environment where the topology changes quite frequently or quite fast. So the node in these networks, they act as a router to forward other node, the packets to other node. As in any ad hoc network, uh, is actually we could say it's a multi hop network. The spectrum is basically used, and due to the fact that a bandwidth that is shared by a different node, that's why it's actually a limited. Okay, so we could say these mobile ad hoc networks are having a highly dynamic topology. So yes, this is one of the feature we could also add, highly dynamic topology. So frequently your link changes. Again I could say uh, your node can act as a router to forward other nodes packet. Okay, so we could say this is actually another property. So node can I could say node act as a forwarding node. All right, then another we could say manet enables spatial spectrum reuse due to limited bandwidth. This we already discussed, so that's why I'm just writing it down. Limited bandwidth to each node. Alright, so these are all the properties of your mobile ad hoc network. Okay, so next we'll see is actually a VANET. So okay, VANET, I just forgot to pick a diagram. Okay, no issue, I'll just make that particular diagram. So okay, so first I'll just explain and later on I'll just draw the diagram. So actually VANET is another category of your ad hoc network, and which is actually very popularly known as your vehicular VANET or vehicular ad hoc network. So in general, ad hoc networks, what we have is an which is formed by actually different vehicles moving on a road. So they could create one network and they'll be working in a vehicular ad hoc network. So what we have, as you can see in a in what we could say, okay, fine, I'll just create a diagram because I don't have an appropriate example to tell you that how it happens. So consider this to be your road. I'm just drawing vehicle to be a circles. 1, 2, 3, and this is 4. Okay, these are actually vehicle. I'm just writing it as vehicle 1, 2, 3, 4. Alright, so this is communicating with this one. This is communicating with this one. Again, this one is communicating with this one. This one is this one. Okay, that's enough. So again, we could say we will require some access point. Why it's not working? So we could say this is your roadside access point. All right, then obviously if it is something like this, so this will be again providing you some kind of data. So again for these two we have already done, so again there has to be another access point which will supply to another. So this is to this, this is to this. This is again the same roadside AP. That's it. It's actually a vehicular ad hoc network. So as we can see that we have actually 4 vehicles on a road which are different, who want to communicate with each other, and each of these vehicle they have something, an electrical equipment or electronic circuitry which is known as the OBU. Hmm? So I think you know OBU. So it's actually onboard unit. So these onboard unit in each of these vehicle, they have a capability to talk, so, capability to talk to something, or we could say to RSU. So that means you have here onboard unit, and for this I could say roadside unit. In general I don't write this AP, and many of the times this is even considered as RSU. Okay, so understand that is this is actually a onboard unit, this is roadside unit. So in general whatever OBU you have, it has a capability to communicate with RSU, each of these vehicle. Okay, so these are like actually access points. So these all two are actually our access point, and we know we could create those things using your Wi-Fi. So these access points are basically installed on a roadside, that's why they are called as RSU. So these vehicle, they can talk to each other And as we can see in this particular figure, that we have actually a double-sided communication. So we could say it's a double-headed arrow. So in this actually vehicle based communication, or I could have used a different marker, but okay, fine. So consider these and this one. Okay, so those are actually signifying that there is a communication that can take place between these different vehicles and the other one, like from this access point to this one, and I think this one and this one. All right. So whichever things I have marked now, uh, we could say that those one are actually basically, you could say, uh, they are actually RSU unit. They are making capability of OBU to have a communication between each individual vehicle. Okay, so we have actually two types of communication between the vehicle, and the other one is between actually your vehicle and a roadside unit. Obviously, then only it will act as your VANET. So whenever it's a VANET, it's not simply like they'll communicate among themselves as if they want. There has to have a RSU and OBU. OBU must be connected to RSU, and another link will be OBU connected to another OBU. So that entirely comes out to be a VANET, right? So this is vehicular ad hoc networks. Okay, so these vehicular ad hoc networks are actually very useful because they can help in spontaneous data exchange, uh, or we could say exchange of data transmission between these different vehicles. So the vehicles, they can talk to each another, and that is a good reason for this ad hoc technology offers a different thing. Okay, although we could say, I think I should just write down a key parameter like spontaneous data exchange between vehicle. Okay, so the key component of we could say the VANET is actually a key component of what it is nowadays is called as ITS. What is ITS? So it's actually a intelligent vehicle systems. Nowadays your cars are becoming smarter day by day more than you. So we could say we could use variety of different communication technology in making them smart, like your WLAN means your, we could use your Wi-Fi as well as your Bluetooth, or anything whatever you need. So even like your LTE you could use, that means your cellular tech can be useful for you. Okay. So it consists of your actually inter vehicle and vehicle to we could say infrastructure. So simply like whenever it's a VANET, they must be operating in two different communication. So it is actually a inter vehicle. Okay, so which is actually known as V2V, and another is actually in V2I, which is actually your vehicle to infrastructure. Okay, so in these two different modes they'll operate. So this is actually quite different than your MANET, and they follow a predictable pattern, like they could only work along the road. Okay, so you will say I have parked my car and in a parking there are 10 vehicles, so they could communicate with each other. No, I'm sorry, this could not happen because there is no AP. All right, so this is actually different than your MANET, and they do follow a predictable pattern. That means they could communicate to each other when they are on a road, and if the VANET is implemented, like access point is being deployed. Okay, so they have actually a higher mobility, and we could say this VANET is actually having highest mobility, not just highest mobility than your MANET actually. Always we need to compare. So this is actually your MANET. All right. So we could say MANET versus VANET. So just before that, I think I would cover something else. So what we could say, what are the advantages of your I think in previous day space, yes, I would just write it here so that I'll have a proper comparison space. Okay, so what could be advantages of your VANET? So we could say it's actually a cooperative driving. All right, then information sharing you could do, then value added services could be provided. We could say internet access or navigation that could be even given. So what are these different parameters? So what is cooperative driving? So that means uh, we could say, for example, there is some ambulance driver is there which is actually running out of time, and he need to rush down to a location. So and in that case, consider that siren is not working. In that case, in this kind of network, he could actually communicate with other vehicles saying that I am an ambulance, let me have my path. All right. So information sharing. So if there is one accident at some unknown location at some x distance, so before uh, you reach to that particular destination, if you need an information, because if you know that before wherever that accident took place, uh, I think before that we could say there is another road or there is some another hotel where you could stop and wait for these things to get better. So the information will be shared to you through a network that don't come this side. There is some kind of accident is happened. Either you have your lunch, dinner, whatever things you need to do, and later on, as soon as your traffic gets cleared or that accident resolves, later on you come and go through this path or take another path. And even there could be like internet services, navigation. These are actually value added services into your VANET. So what are the different components of your VANET? So obviously you know different components now. Those are OBU, like onboard unit, which is actually responsible for your data collection from different sensors and communication with each other OBU. Then your RSU is there, roadside unit, which is actually infrastructure which enables communication to outside network. All right. The second thing is your communication technology. So which is actually you could say vehicular ad hoc network, but communication technology here it is different. Here it is called as wireless access in vehicular environment. Okay, so this is generally referred as WAV. So this is actually a wireless access in vehicular environment. Okay, so this supports actually a multi-hop communication between vehicles. IEEE 1609.2, commonly known as your DSRC 802.11p. All right. So if you want, I'll just write a standard here. I'll just write down here wave. Uh, to have, where should I write? Okay, I'll just write here, to have communication between two names. I'll just write vehicle. There is a standard called as IEEE, okay, 1609.2, which is also known as DSRC 802.11p. Alright, so these are components of your VANET. Okay, so what were the component? So there was OBU, RSU, and this communication technology of wave. What is wave? Wave is wireless access in vehicular environment. Alright, so what more we could see? So if I need to elaborate this kind of diagrams, so I could tell you MANET and VANET. I'll just take over this place. So if I need to draw appropriately these kind of VANET network, so MANET and W wireless ad hoc network and mobile ad hoc network, you know it better. So if I need to draw a vehicular ad hoc network, in that case I would say what are the different parts. So there will be an application, then there is actually a certificating authority will be there, then again there will be a service provider should be there. Okay, so this is actually a we could say infrastructure domain. All right, so this will be one segment. So I'll just divide this among three segments. Okay, so this is infrastructure domain. Second would be your V2I. You already know now V2I, what is V2I, and we could say V2V will be the bottom side. So here I need to deploy some RSU with some kind of flexibility to have a antenna. Alright, so these are RSUs. Then again there has to have your vehicle. So it's a vehicle, this is also a vehicle. So in this vehicle, more specifically, if I'll speak, whatever OBU will have, which is actually a combination of your TPM, OBU, and the sensors. Here also it will be same thing, TPM, OBU, and sensor. So this will be model entirely. So whenever we need to draw something, so you could consider these kind of diagrams for VANET. It will be more efficient to say that thing. So TPM will be actually your trusted platform module. Okay, so this is actually, it's not something like I haven't told, I think I haven't told you. So yes, so this is actually your infrastructure domain, and this is your ad hoc domain. So now we have requested a domain. So yes, I was telling you TPM. So this is actually a trusted platform module should be there, and OBD and all those things. No, so uh, why we require this actually TPM? So in general, uh, you know that these kind of modules, and you have actually a different vehicles having a different sensors which collect different information from your vehicle, and you know their behavior and so on things. So in order to maintain those things, or you need to propagate those things to OBD, you will actually require these kind of TPMs. Okay, so different other things, the sensors, they collected data or information about this V2V communication, and they can be shared between your different vehicles to different RSUs, and it can be transferred over to other units. Alright, so I think I have forgotten a connection. So obviously this will be a connection, so it's not a big deal. And here it's a communication. Okay, all right, so this entirely comes out to be your VANET. All right, so this also contain, it's, so VANET is not just a combination, It's just a combination of your infrastructure module and no infrastructure less module. Okay, so they have created a combination of these two things in a VANET, but in a mobile ad hoc network it was not a case. Okay, so I'm not just going to write a comparison point for these things, I'll just explain you. So obviously cost of deployment for your MANET will be quite, it will be a infrastructure less thing. So obviously MANET will have a we could say it's a cheaper, and VANET is actually comparatively higher. So we could say mobility scenario in MANET, obviously this will fail, this will have a larger impact. Frequency, if I would speak with respect to MANET, so it is actually a 2.4 gigahertz, 802.11 ad hoc hai, so I could say that. And if it is a VANET, so whatever we have seen, whatever that wave is, it's actually a 5.9 gigahertz. Okay, so range here is again we could say 100 meters, here we could say 1000 meters. Then we could say partitioning of network is actually a very low, in this case actually frequent. Then mode of operation, man, it is actually obviously you know that it's infrastructure less, and WAN it is actually combination. Okay, so I think I have forgot one more point. In man it actually you need to know that movement pattern of your each node in a MANET mobile ad hoc network is totally a random fashion, but in case of VANET it is actually constrained by your road. So those are actually a comparison point you could say. So those are the important points you need to understand while comparing your MANET and VANET. All right, so what more I could say. Okay, ad hoc network and internet. So whenever it's kind of a case where you need to uh, have a connection or internet connection, I would say more profoundly that if you want ad hoc network having a internet connection, in that case what you would do. So I'll just draw a diagram, so that will give you a brief idea that how I could just deploy internet for my ad hoc network. So again I'll just pick up some of the devices, so I'll just consider a mobile, it's easy for me to tell you. So I'll just make a connection between them to be connected to the, yes. So obviously this is your internet, right, and this is your ad hoc network. You want these things to be connected. All right, so whenever we say that we need to connect ad hoc network with an internet, it's actually simply like there has to have a access point to which they are connected. All right, then there will be a router, then it will be having some web server. All right, so in general you could say this is your IP backbone. All right, so whenever we need to share some data through those things, we need to have some gateway, IP backbone, and obviously a internet service to be connected to your system. So this is actually you could say mobile ad hoc network connected to internet. What it will do is simply like this is actually a kind of you could say it's actually a kind of application of your IoT, but this is actually in a base form. So in general, whenever we need to deploy MANET or a ad hoc network to an internet, in that case, we need to pass on this information to some access point through a gateway, and later on it will be passed on to your IP backbone, through which it will be connected to an internet. So it could be made simply like a bidirectional communication, or like your what we could say, your IoT application. Okay, so now I think I need to discuss what are the different constraints and challenges. So constraints are actually I think I have told you those things, but still I think I need to explain those. So this is actually infrastructure less. So that is actually a we could say it's lack of centralized entity that dictates network management that has actually distributed over your network, leading to a host of problems. Okay, so that's why infrastructure being infrastructure less is actually a constraint in your ad hoc network. Okay, then another thing you could see as a constraint is actually dynamically changing of your, what we could say, a network topology. So dynamically changing network topology. All right, so it's actually unpredictable. Okay, and it's actually frequently routing your routing changes, then there is actually a packet loss. So this is also again, you could say, it's actually one of the major constraint in your ad hoc networks. Then again there is actually a problem of your mm, physical layer limitation. So what happens is actually in physical layer limitation, uh, radios used generally in actually, we could say, in a broadcast mode and are limited to power and range. So this leads to issue uh, like hidden and exposed node. So you have in a computer communication related or CCN or computer communication network related subjects, you might have seen this kind of hidden node and exposed node kind of problem. So in ad hoc network generally this is actually a biggest problem in due to just physical layer limitation. So last point I could even say there is actually a limited link bandwidth. So how come limited link bandwidth? That nodes communicating with each other over actually a bandwidth uh, constraint or error prone channels, which causes actually a, we could say, a delay or congestion issues at the nodes as much pronounced. So that's why, and even multiple nodes link out to be a limited link bandwidth problem. Then I could say, if I would consider a challenges, then in that case the problem is actually challenges, actually not a problem, because there is a difference between problems and challenges. Um, so the first thing I could consider is actually scalability. So it's actually providing acceptance level for a service in presence of we could say large number of nodes. So I could anytime I should be able to accelerate those kind of levels. So typically we could say, if I'll raise this scalability na, so in that case my throughput will decrease. I think after these many days you understand a throughput. So my throughput decreases at a rate of, I think it is called as actually under root of n. Okay, so as soon as I'll increase the scalability, throughput will be decreased by under root of n. So now you will ask what is n. So n is actually number of nodes. Okay, so that's actually one of the challenge that I need to mitigate. Then there is actually one of the major challenge, you could say, is actually quality of service. So it means like what kind of guarantee you offer in terms of your bandwidth, delay, jitter, your packet loss probability. So it should not happen simply like I have 100 nodes and my network does have a capability of 100 nodes to deliver some simply like appropriate bandwidth, delay, jitter, whatever this what we could say packet loss probability is there. So how much less would be this thing? It should not happen like if your system was running fine with 100 nodes and I just insisted for more of the 5 nodes, and it disturbed my entirely all things, and the problem of packet loss probability increased. So I don't want that probability to increase down, then I don't want a delay to incur. So that's why quality of service to be maintained. So that is actually one of the challenge. Then again, due to a limited bandwidth and unpredictable changes in RF channel characteristic, the quality of service gets degraded. So for that you need to always focus on this QoS. Okay, scalability and all those things that we could say, yes, it's a challenging part, but that will be manageable. But while managing this thing, you need to understand that quality of service should not degrade. Okay, then again, one of the main challenges is actually energy efficiency, which is actually always considered as a major impacting factor. So actually, the individual node in actually a ad hoc network, they do have a limited battery level. It is not simply like that you have deployed a one node and it does have a huge battery supply and all those things. So obviously they have a limited battery power. So nodes need to cooperate with other nodes while we are relying for their information. And uh, whether it's IoT or something like that, if there are multiple nodes, their work is to aggregate the data and send that particular thing. Each node should not efficiently work 24/7 to supply data. It's simply like some of the times the data gets aggregated from each individual node and then it is passed on. Okay, so that is actually an important thing, energy efficiency. Okay, and one of the, you could say, in all these things, the major problem is or challenge is security. That's a major thing because it's actually a open medium. Okay, and next is actually your nodes are actually prone to malicious attack, then infiltration, eavesdropping, interference. So whenever you are designing some kind of ad hoc network with actually having a larger scalability and all those things, in that case you need to consider actually each individual node should not be uh, or you could say, if I would introduce much of the scalability, in that case it should not happen simply like there is kind of eavesdropping or due to multiple nodes are there, so there is actually interference, so that kind of security issues are there. So you need to consider those while designing these kind of uh, different things. So I think we need to understand what are the different factors which are actually being considered while we are considering ad hoc network. So in actually implementing ad hoc network would be challenging while we use actually heterogeneity of devices is actually one thing. So we could say I never want my system to have a homogeneous. Obviously it has to have a heterogeneous, because heterogeneity is actually typically like different types of devices you could actually make them to communicate with each other. So it's always assumption that your system should be heterogeneous, mobility devices should get into your network. They'll have their different capability, they have their different capacity, they have their own power, they have their own battery life, their shell life. Then they could make you help you in a cooperation of this network forwarding packets and all those things. So whenever we consider this ad hoc networks, we need to understand that these are different parameters that we need to understand, we need to implement, and which mode to utilize. Like in general we could not say that all the ad hoc networks are actually infrastructure less. Yes, it's a true fact whenever it comes out to be ad hoc, but whenever it comes out to be a vehicular ad hoc, in that case we have already seen that it doesn't happen, that it's actually not a true fact that we can combine those things in a advantages. Obviously cost will raise, but in that case you need to understand what are the differences and what are the advantages of these two networks, and while we deploy it in a different mode, So that will be a betterment of our ad hoc networks. Okay, so this is all about your ad hoc networks. I hope you understand some of the concepts of manet and vanet. So thank you for your time. Let's see in your next video. Hello and welcome to the new segment of ad hoc network, which is actually one of the important concept, or we could say one of the important parameter that we need to consider while we are learning about wireless network. So yes, ad hoc